Hi and welcome to Unit 2, Topic 3, Video 8. And in this video we're going to continue exploring the inverse matrix. So where matrix A is A, B, C, D, what is A inverse, A to the negative 1? And we're actually going to generalise this and then apply it to a couple of examples. So hopefully this video won't be too long, but I do tend to ramble, so let's see how we go. We're going to start by generalising. So what I'm about to do is a really important feature of understanding where the inverse comes from, this generalisation. But it's probably not something you're going to need to reproduce. So I would put everything down, just watch, listen to what I'm talking about, and hopefully understand the process. It will help you with that higher end algebra, but then the application in the examples is going to be a little bit more important to start with. So let's see how we go. I want to work out what A inverse is generally. So we're saying that A, that's a pretty bad start, A inverse is equal to I. And so what this means is that AB, let's move it across to here, ABCD times by A inverse is equal to 1, 0, 0, 1. Now this is where things get a little bit out of hand, just for a short while, but then we'll bring them back together. So I'm going to say let A inverse equal W, X, Y, and Z. So I've just gone to the other end of the alphabet, but of course you could do whatever you like. So W, X, Y, and Z are my A inverse values, and this of course is a matrix. I can multiply A and A inverse together, and it gives me AW plus BY, and then AX plus BZ, and then CW plus DY, and then CX plus DZ. And that's going to be equal to 1, 0, 0, 1. Now, this means that we now have 4 equations that we can technically solve simultaneously. Now, of course, we've got 8 variables, 8 unknowns here. We're not going to find a numerical value for W, X, Y, and Z. What we want to do is find W, X, Y, and Z in terms of A, B, C, and D, such that if we knew the numerical values of A, B, C, and D, we could just find W, X, Y, and Z. And that's why this is called a generalisation. So I know this. 1. AW plus BY equals 1. Equation 2. So my pen's just stopped writing. AX plus BZ is equal to 0. Equation 3. CW plus DY is equal to 0. And then equation 4. CX plus DZ is equal to 1. Now, this leads to some opportunities to do some substituting and solving. So this is going to be my approach to this. Firstly, I'm going to look at my W and Y because they come in pairs. So WY and then WY. So I'll be able to do something with W and Y. And what I'm actually going to do is I'm going to start by finding the value of Y in terms of A, B, C, and D by starting with this. AW is equal to 1 minus BY. And in fact, I'm not going to start with this. That's not nearly as nice. Let's start with this one. CW is equal to negative dy, and therefore W is equal to negative dy over C. I don't have to worry about the 1 now, which helps a little bit. Okay, so that's equation 3 still, and then I'm going to sub equation 3 into equation 1. And so now I get, instead of W, I'm going to substitute in what W is equal to. I get A times negative dy over C plus by equals 1. And I'm taking my time a little bit here, so bear with me. Gives me, well actually I'll write it down as by minus AD over C equals 1. I'll just swap them around. Oh sorry, there should be a Y there as well. And put the A in as part of that. And then I'm going to multiply everything by C. Seems like a good thing to do, just to get rid of the fraction. So I've got, sorry, this pen is being a bit funny. BCY minus ADY equals C. And now I can factorise the y value out. Y BC minus AD equals C, and then y is equal to C over BC minus AD. Okay, I would strongly urge you to pause the video now and just check you understand how I've got to there. Okay, so you've come back. Hopefully you're fully clear on where we are and how we got there. I've got my y value, and now I'm going to tell you that my w value is equal to negative d times by this y thing here, which is C over BC minus AD all over C. I've taken that from there and just brought it in, swap the y for what it's equal to. Now this is quite handy. I can put the d in with the c, but this c, I've got this whole thing here divided by c, which cancels that, leaving just a 1 there. And so it gives me negative d over BC minus AD. So I'm going to make a slight technical change just because there's a mathematical norm that takes place here, and it's important that we get that norm right because it's what you're going to see in the textbooks and code. So we've got y equals this stuff here, but actually what they use is y equals, and then they multiply top and bottom by negative 1, which is okay to do. It gives us negative c over AD minus BC. You'll see why this is important later. And we do the same thing with w, and it gives us d over AD minus BC as well. So it actually just multiplying the top by negative 1 is clear. Multiplying the bottom by negative 1, the AD becomes positive, the BC becomes negative, and we just swap them around naturally. I'm also going to tell you that if we go up to equation 2 and 4, we can get the same result for x and z. And so what we get here is that z is equal to a over AD minus BC, and x is equal to negative b over AD minus BC. And in fact, we get this result. A inverse is equal to, it was w, so d over AD minus BC, and then negative b over AD minus BC, negative c over AD minus BC. Pen's going a bit funny again here. And then a over AD minus BC. And that's our A inverse. So just to give you a bit of an example, to make sure this is clear, if I knew the value of A, let's say that A was equal to 273 negative 2, well, this is my A, B, C, D, and I can substitute those values in to get my A inverse. So this is really nice and works well. We are going to simplify this process a little bit later, and hopefully you're recognizing now that we have a pretty equivalent denominator. That's going to be hugely important. So let's have a look at a couple of examples. Oh, here's one where I know A. So let's do this quickly. We've got A inverse, of course, is equal to, and I'm going to write that whole big thing out, it's equal to D over AD minus BC. That's equal to negative B over AD minus BC. Then it's equal to negative C over AD minus BC. And it's equal to A over AD minus BC. Okay, now again, hopefully you recognise this equivalent denominator. So why don't we work it out over here? AD minus BC is equal to negative 3 times 6 minus 7 times 21. Don't know why I picked these numbers, but I did. That gives us negative 18, for lack of a calculator at the moment, 147, 157, 100, negative 165, I believe is our value there. So that was a very clever one to pick. And now I can put that in with my appropriate values. So I get D, which is 6 over negative 165, negative B, which is negative 7 over negative 165, 21, but negative 21, negative C over negative 1, negative, sorry, pen again, negative 165, and then 6 again over negative 165. Now, 165 is not divisible by 7, but it is divisible by 3. It is 55 when you divide it by 3. So I'm going to do some just cleaning up here. and that is that this becomes negative 2 over 55. Here, nothing changes except I'll take away the negatives. 7 over 165. Here, I can divide by 3, giving me 7 over 55. And then here, I can divide through by oh, sorry, this shouldn't be A is negative 3. That shouldn't be 6. That should be negative 3. So negative 3 divided by that becomes positive. It becomes 1 over 55. And there we go. Okay, so you've seen now how we can use the generalisation in example 2. You can already see example 3 where I'm going to finish this video, and then you can see in the next video we'll talk about the determinant. There is not an inverse of the matrix D. Why not? Okay, well, let's imagine there was, and just start finding it. So if we wanted to find D inverse, it would be equal to that big horrible thing there, which we've got up here. I'm not going to copy it across. I'll put a squiggle line. Worst videoing ever. But remember, we started by finding AD minus BC. In this case, that's equal to 3 times 4 minus 6 times 2, which is 12 minus 12, which is 0. And then our D inverse is going to be equal to, remember we had D over AD minus BC. So in that case, that's 4 over 0. And then we get negative 2 over 0, negative 6 over 0, and 3 over 0. Now, if you're on top of this, you'd be screaming at me through your screen right now, because obviously if we divide by 0, we get an issue. So if that AD minus BC is equal to 0, we've got some problems. Hence, some matrices are not invertible. They're non-invertible matrices, and it's got some special properties to it, which we'll get to. And in a lot of our context, it gives us some special properties as well. Okay, so that's the end of video 8. All the best.